Anil Kumar sharing with you some difficult test questions based on circle theorem. Question number 13. ABCD is a cyclic quadrilateral with tangent TA. Show that ABCD is also a parallelogram. You can pause the video, answer the question, and then look into my suggestions. A cyclic quadrilateral means quadrilateral with 4 vertices on the circle, as shown here. Now, from the circle theorems, we can relate the angle between the tangent and the chord, this is the chord TA, and the angle 55, with the angle inside the quadrilateral using alternate segment theorem. So you have to look for the angle which is formed opposite to the segment which is formed by the tangent and the chord. So that is this angle, right? So the angle which I have highlighted is also equal to 55 degrees. Now, we also know, so that is how we get the angle ABD. So angle ABD is equal to angle TAD, which is 55 degrees. Now, let's look into the quadrilateral. Cyclic quadrilateral means sum of opposite sides is 180, right? So angle the angle A, which is DAB, plus angle DCB should be equal to 180 degrees. This is from the property of cyclic quadrilateral. Opposite angles sum is always 180, right? Is 180 degrees. Now we can solve for angle A, which is angle DAB, equals to 180 degrees. Take away, we know DCB is 105. And that gives you 75. So this angle is 75 degrees. Now once you know this angle, you can find the other angles also. Sum of angles in a triangle is 180, right? degrees. So that should help us to find ADB. So angle ADB equals to 180 degrees. Take away these two, that is take away 75 and then take away 55. So when you take away 75, it becomes 105, and 105 take away 55 will be 50 degrees. So this is 50 degrees. Similarly, we can find the other angle. You will also use now cyclic quadrilateral theorem, but it's better to use, let's do angle CBD should be equal to 180 degrees, take away 25 and 105, right? Let's take away 105 and then 25. So if I take away 105, I get 75, take away 25 is 50 degrees. So this one is also 50 degrees. Okay. Now, we need to show that ABCD is also a parallelogram. How can you do that part? In a parallelogram, we have to show that two lines are parallel. So if we have a transverse line, in that case, sum of interior angles is 180 degrees for parallel lines. So if we have sum of interior angles as 180 degrees, we can show that the lines are parallel. So let's look into the sum now. So let's add these sums and figure it out. So we add these numbers, what do we get? We get 105 plus 25 plus 50, and that is 75 plus 105, 180 degrees, correct? So we know this is 180 degrees. So we know that these are two parallel lines and that is the transverse line. So that shows that AD is parallel to BC. Is it okay? Now similarly, let's now figure out the sum for the other two. So we could add these, for example. So if we add these, what do we get? We get 75 plus 50 plus 25. Right, so we got 75. So inside angles. 75 plus 50 and then 25. 75 plus 75 is 150. So we know that this is not parallel. So these two sides are not parallel. Correct? If you try these two, then also we get 105 plus 50, which is 155, and 155 plus 50 will not be 180, right? So actually it is not a parallelogram. So we see that this sum is not parallel. So DC is not parallel to AB, right? DC is not parallel to AB. So I think there's something wrong in the values. It is not a parallelogram. Show that ABCD is also a parallelogram. No. We can only show that AD is parallel to BC. So it is not a parallelogram. However, we have proved that AD is parallel to BC. Okay. So I think some values we have not taken correctly. Either way, in such a case, it is not a parallelogram. However, there are two parallel sides, and those two are AD and BC. So these sides are parallel. Okay. So it's also a learning experience, and I hope you appreciate it. Feel free to share your comments, subscribe to my videos, and share them with your friends. Thank you, and all the best.